Okay, so for our information assurance project, we chose the field of public safety and security because this is always a very relevant field, especially now with many security breaches and unsafe situations in large cities, which is why we chose a project called City Security with Cameras. This includes regular security cameras, but also CCTV and other government cameras. First, we will explain our methodology, including a case study on Japan, where CCTV cameras have improved largely over the last couple decades. Then we will discuss the challenges faced with such CCTV and other camera systems. Then we will explain how our system is going to work and what elements it includes, and then we will end with a conclusion to briefly summarize our findings. So we chose camera surveillance as our main topic, and a surveillance system is just a system that lets you keep an eye on whatever is going on in any area of interest. For example, in a dark alley, we want to know what could happen there. For example, if a robbery could occur there, we want to see what happens, and we want to be able to record all this in order to find the person who did this and find potential victims of this kind of event as well. Other places where we could use camera surveillance are laboratories or other places where dangerous situations could occur, which might or might not be because of someone doing something wrong. For example, a system could overheat, or a reactor may not function properly and catch fire. We want to prevent all that too by using camera surveillance. So this includes three main parts. The first being live footage of any spot of interest. So we want to be able to look as something is happening. For example, a security guard might want to see what is going on in all sides of a building, but also the security guard might want this footage for later inspection, so he might miss something or go and do something else, act on something else that happened, and then he might miss crucial information, so then he can watch it back using the stored footage. And of course, we want to be able to process any videotapes. For example, if we want to recognize faces, or if we want to enhance the video and find license plates for any event that might happen, such as a car accident. So we started our project with a case study on CCTV cameras in Japan. We chose Japan because before 1998, they hardly had any camera systems, and after that they had a rapid growth, so we can easily see over a shorter period of time how this system evolved. So after 1998 in Japan, mainly in Tokyo, they implemented many camera systems in places such as shopping centers, roads, public transportation, and stores in order to enhance security. And from 2005, we see the largest CCTV network in Japan, based in Kyoto, including 85 connected CCTV cameras. What we do see, however, is that the priority in Japan was on high value areas rather than on high crime areas. We think this is mainly because places where high value stores, such as watch stores, jewelry stores, they have more money to invest in such systems, and for them there's a large risk involved if even one incident would happen that could cost them a lot of money already. So we think that's why the priority is on those areas. with one exception, and that we found very clearly, and that is the Tokyo red light district, where they installed 50 cameras because the crime rate is 185 times higher than the city average there. So the government wanted to get a little more grip on that. We also see that in recent years, Tokyo and Japan as a whole are surpassing Western countries quite fast because they invest a lot of time and effort in these systems, and they are also working on more advanced technologies to analyze the footage that they record, and they, for example, work on systems that let you interact with police and government whenever something happens through any of these systems as well. So the challenges we see in smart surveillance are training data for machine learning algorithms. We know that if we want to use machine learning to analyze all this footage, then we will need a large data set of all kinds of people and events that happen, such so that the algorithm can learn how to analyze these tapes properly. But of course, we do not always have very large data sets to teach the algorithm how it is supposed to act. And of course, there are privacy issues with this approach as well. The next one is data fusion with many different inputs. This is a challenge because there are many different cameras of many manufacturers, and in order to effectively work together for these cameras and see how an event can spread over a system or over a city, or how anything could be predicted in other parts of the city based on camera surveillance in other parts. All these different inputs need to be collected somewhere and need to be synchronized in order to analyze them all properly and to see the bigger picture that they span up. Then we have the data transport, which might not be sufficient because if we have many cameras and sensors, they can produce so much footage and other output, and this might not be this might be too much for regular internet connections to all upload to the cloud so quickly and to process it so quickly. So we think that in the future a new 5G network might help a lot with this issue, but as of now it's still a challenge on how to make all this all this data run smoothly and be transported smoothly without too much loss of quality. And of course, the response time must be quick. We cannot have a system that takes minutes or hours to process all this data, because in some incidents, a camera system must be really fast and make a decision really quick. For example, in a car crash, we want the police to be called immediately and not after an hour or so. So our proposed system is a surveillance system based on cloud computing. It gathers and analyzes video streams, optimizes video according to network so that everything still gets uploaded smoothly and instantly, and it stores all the tapes securely and efficiently. It is composed of 4 components. The client component collects the data and sends it to the cloud computing servers. The cloud processing server receives all the data, analyzes all the footage, and it has to respond accordingly. So, for example, it has to set an alarm off if something goes wrong or if an unexpected event happens. The cloud storage server has to store all the footage that after we don't need it anymore, but we might need it in the future again. So it has to be securely stored. And lastly,